Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson about the revision of logic. In the last lesson, we were reminded about open statements and propositional connectives. We learned how to use universal and existential quantifiers and how they can change the nature of an open statement. Today, we will study the concepts of argument and validity. We will also use the rules of inference to demonstrate the validity of a given argument. Are you ready, students? Then we will begin. First, we will define the term argument. The kind of argument we are talking about is not the same kind as you might have with your brother or sister. In formal logic, an argument is an assertion that a given set of statements called the premise, also called the hypothesis, leads to another statement called the conclusion. The conclusion is also called the consequent. An argument is valid if and only if the conjunction of all the premises always implies the conclusion. If we assume that the statements in the premises are all true, then a valid argument's conclusion must be true. This is called a tautology. If an argument does not meet these conditions, it is not valid. An invalid argument is called a fallacy. Let us consider this statement. If I swim, I am wet. I am wet. Therefore, I am swimming. That does not sound right, does it, students? I do not think this is a valid argument. But we must learn how to prove that an argument is invalid before we can know that it is false. Our premise is denoted by P. I swim. Our conclusion is denoted by Q. I am wet. The argument is that P leads to Q. we can test the validity of this argument using a truth table. The table must demonstrate that all the premises taken together always imply the conclusion. We will let the statement, "If I swim," be represented by P, and Q will represent "I am wet." We can use these expressions to represent the argument symbolically like this. If this implication is always true, the argument is valid. Now we can construct a truth table to assess the possibilities. The truth table for this statement looks like this. Observe, students, the third line in the fifth column. That shows us that the conclusion could be false even while both the premises are true. The argument is shown to be invalid. In other words, swimming may get you wet, but even if you are wet, that does not mean that you must be swimming. It is time for an activity, students. Please test the validity of this statement by constructing a truth table of your own. Here is a hint. Your table should have 4 rows and 7 columns. Please get started now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Were you able to complete your truth tables? Let us consider the validity of this argument. Let us assign P to represent I am fit and Q to represent I am an athlete. The symbolic form of this argument is represented this way. It can be considered valid if this implication is always true. It will be a tautology. The truth table looks like this. What does the table tell you, students? Correct. The argument is valid. Well done. As we have seen, truth tables are a useful tool for determining the validity of arguments. But sometimes arguments can be complicated or have many premises, so that constructing a truth table can be very time-consuming. We can take a shortcut around this by applying the rules of inference. If we carefully apply the rules of inference, we can determine whether or not an argument is valid. Please get ready to make a note of the rules, students. They are as follows. This is the principle of adjunction addition. It states that if P is true, then P or Q is also true for any proposition Q. This is the principle of detachment simplification. It states that if P and Q is true, then P is true. This is the principle of conjunction. It states that whenever P and Q are true, the statement P and Q is also true. This is called the modus ponens. It states that whenever the implication, if P, then Q, is true, and the hypothesis or premise called P is true, then the consequent or conclusion called Q is true. This is the modus tollens. It states that whenever if P then Q is true, but Q is false, then P is also false. This is the principle of syllogism. It is also called the transitive property of implication. The last rule is called the modus tollens ponens. It is also known as the disjunctive syllogism. Let us try to apply the rules of inference in an activity, students. Here are 2 arguments. Using your notes on the rules of inference, determine which rule applies to which argument. You may start right away.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. The first argument states that whenever the implication, if P, then Q, is true, and the hypothesis P is true, then Q is also true. We apply the 4th rule, modus ponens. The second argument states that if P is equal to Q and Q is equal to R, then P is equal to R. This is the principle of syllogism. Well done, students. That is all for today's lesson. We have learned about arguments, validity, and the rules of inference. Until next time, thank you, teacher. Thank you, students.